Okay, let us now build the find operation. It is exactly same as the single linked list. We'll start searching the target from the first node of the linked list, and we'll go until we reach the last node or the end of the linked list. So we need a pointer there, node pointer p, and we'll write a for loop this time, and we'll start from the very first node. And so lstptr, that's the list pointer, arrowhead, and then p not equals null, and each time we'll move to the next node by using p equals p arrow next. Obviously you can start from the last node and you can move towards the first node using the p equals p arrow brief. That's also possible. So I'm using the p equals p arrow next, and each time what we need to do is to check whether the content of the node is our target or not. If that is our target, that means we find the target there, and we can just return the address of that node. Otherwise, if we come out of the for loop, that means we have reached the last of the linked list, so we can just return null in that case. So if the target is not found, we'll traverse throughout the linked list and we'll go to the end of the linked list. In that case, we come out of the for loop and we return null. Otherwise, in between, we get the node, we get the target inside the node. We are just returning the address of that node. So once the find is done, we are now good to write the insert after and insert before operation. We'll be using this find operation from there, insert after and insert before. Let's first write the insert after. Now the insert after operation is going to insert a node with the data passed to this insert after the target node. Okay, so first of all, what we need to do is to search whether the target node exists or not. That means whether a node containing that target data exists or not. So we'll just use a pointer p, and we'll use that find operation. We'll make a call to the find operation. We'll pass this lstptr and the target from this function to that find function. Now if p is null, that means the target does not exist in the linked list. In that case, we are going to return 0. As this function insert after is going to return 0 if it fails to insert the new node after the target node. So otherwise, if we are here, at line number 311, that means we get the target there, and the target node is pointed by p. So let's draw a picture and try to understand this situation and develop the algorithm first, how we can do the insert after operation. Before that, let us consider one special situation. If the target node is the last node of the current linked list, that means we need to insert after the current last node. In that case, what we do, we just make a call to the add last method in order to add the new node as the last node. Okay, so here we go. If that p equals with lstptr arrow tail, that means the target is there in the last node and we need to insert after the last node. So we can just make a call to add last and just transfer this lstptr there to the add last and the data. So that will actually do that. Otherwise, we need to develop the algorithm for adding at any point in between. So let's draw a picture and first of all develop the algorithm. This is the situation. Just look into that image. We have 3 nodes there in the current linked list and our target is say 20. That means we need to insert after the node that contains 20. So this is 20 and our data is 30. What we need to do is to create that new node. That's the first thing. Okay, so we need to create that new node first, and we'll be using the malloc operation and we'll create that new node. So the new node is, say, this is q. That's the new node and that is created at address 4000. We will keep that data, that is 30, here in this new node, and we need to insert this new node after the target node. Say the target is 20, so we used that find operation and the find operation returned the address of this node in the pointer p. We have used that pointer p to get the address there. So p is 2000 and we need to insert this node pointed by q just after the node pointed by p. That is 2000. That's the second node. So what we need to do is to update this pointer. This is going to point to our new node. That means this node in green, and then we need to update this one as well. That's going to point to this green node as well. And also this green node is the next pointer of this is going to point to this 3000, and this previous pointer is also going to hold 2000. That's the second node's address. So first of all, what we need to do, we can just update the previous and the next pointer of q. So q arrow next, that should be actually p arrow next. You cannot use tail because it's not going to happen that tail is going to be the next node all the time. We may have more nodes there. Okay, so q arrow next equals p arrow next. So p arrow next is 3000. That is copied here. Let me use a different color there. Okay, blue is good. So 3000 is copied here. And so this is going to point this node. And then q arrow previous. Q arrow previous. That should be p. That's 2000. That is copied here. So this is not null anymore. So this is going to point this node. And then we need to update these two pointers, this one and this one. Okay, so p arrow next is going to hold the address of this new node. So p arrow next, that's going to be actually 4000, that is q. And this one, now once you are updating that p arrow next with q, no longer 3000 is there in this node, right? P arrow next is now q. That means we have 4000 here. So this link is not existing. Now p arrow next is not pointing to that 3000. It's now 4000. So this is actually pointing to this one. And then we need to update this pointer here. So you can access this pointer by using this tricky one. Q arrow next, that is actually 3000. That means it's this node. And then what you can use, arrow prev. So you are actually referencing this particular pointer here. Just q arrow next is going to give you the address of this node, and then arrow prev is going to refer this particular pointer field there. And we are going to update this pointer field, and it's going to be q, right? So it's equals q. That means we are assigning this 4000 here in this pointer field. So this is now going to point to this, and you have successfully inserted that node just after the p, I mean the node pointed by p. So you can see that q is now just the next node after our target node. So that's how we do this. So let's update this code there in the else part. So first of all, what we need is to create that new node using the dynamic malloc call. So if the queue is null, we need to just print a message and return 0 to the caller, because we are unable to create the new node for insert after, for doing the insert after. Otherwise the node has been created, so we need to update the pointers according to the algorithm that we just developed. So q arrow next is going to be p arrow next, and then q arrow prev equals to be p, and then p arrow next, that should be q, and then again q arrow next arrow prev, that's going to be q. It is not necessary to have this parenthesis there, although you can have that to make it clear. Otherwise you can go without the parenthesis as well. So this is the code. I mean, we have successfully added that, and then we need to return 1 because we have successfully added that node there in the linked list. So we can return 1 now. But before doing that, what we need to do is to increment the node count by 1, because we have added 1 node there. So lstptr arrow node count plus plus. So now I'm going to make a call to this insert after operation, and then we'll check that. So we'll go to the main function there, and we'll write the call to this insert after operation. Okay, we have the menu option 8 for find, and we do not have any menu options for insert after or insert before. So I'm going to add them here as menu option 9 and 10. So printf, and this is going to be 9 insert after, and then we'll have another one for insert before. So this is going to be 10, and this is going to be insert before. So the rest of the menu options are to be updated. So this is going to be 11, then 12, then 13, then 14. Okay, so let me call the find operation first, and then we will just update the call for insert after and insert before. Before updating the case, we have a little correction here. Here in the insert after operation, after creating the node, what we need is to assign the data into that node that we forgot to do. Okay, so it's done. Now we can just go ahead and update that case from where we can just call these insert after operation and find operation. I'll show you that I have written that. Okay, so here is the find operation call. You can see that I'm getting the target from the keyboard, and then I'm just making a call to the find operation there. You don't need to declare all this target variable and the current variable. They're there. You can take a look into the beginning of the main method where I have declared all these variables. The current is a pointer, a node pointer. Now if the find fails to find this target in the linked list, it returns null. So if the current is null, in that case we are just printing a message. The target is not there in the linked list, otherwise we are printing that the target exists. Now in case 9, we are actually getting the target and the data for the insert after operation, and then we are making the insert after operation call here. You can see that if that returns 1, we are just printing a message, insert after was successful, otherwise we are printing that insert after failed. So now we need to just update this quit. It should be 14, as the menu option 14 actually corresponding to that quit. Okay, so we are done with this. I think we can go ahead and compile and run this. But before doing that, I would encourage you to do the insert before operation by yourself. So pause the video here and develop the insert before operation by yourself. The code for the insert before operation is just going to be same as insert after operation, except at one place. I'll show you that where the code is going to be different. Now you can imagine this section, line 350 to line 353, that's going to be different for insert before. Just draw the image of a double linked list and try to update the code for insert before operation. And one more thing that you need to update is that if the insert before is called and the target node is the very first node, here the target node, if the target node is the very last node, we are calling the add last operation. But in case of insert before, if the target node is the very first node, you'd require to call the add first method, because in that case you need to add the new node before the first node. So just update these things and try to develop that insert before operation. And once you're done, just get back to this video and resume this video, and it will compile together. Meanwhile, I'll just update the insert before operation as well for you, but I want you to do that by yourself. So pause the video. So here is the insert before operation for you. As you can see that if the target node is the first node, then we are making a call to the add first method, as I said earlier, and just updated these 4 lines. So you can just get these 4 lines by drawing the picture, and I want you to do that. If you failed, if you are still unable to write that insert before or understand these particular 4 lines, then I want you to just draw the image and do this using some dry run, and that will just explain everything to you. So let's move ahead and try to compile this. Also, I have make a call to this insert before from the main method, from the menu option 10, as you can see it here. Okay, again we are just getting the target and the data. You can see that, and we are just making a call to the insert before operation, exactly as I did for insert after. So we are just ready to run this. So I'll just compile that. Okay, here we go. It has been compiled successfully. So I'm running the program. I'll create a linked list using the random numbers, 5 elements, and linked list has been created. Let me display the linked list. So here is the linked list. Now I'll use that insert after operation, that's 9, and then I'll use the target, so the last node 965, that's my target, after which I want to insert, and I want to insert 100 or 1000 there. So insert after was successful, and we can just display the linked list. You can see that 1000 is there just after 965. We need to give a space there while displaying that. So it's okay now, and I'll just run that once more. Insert after is 9, and I'll choose any node in between. That means, say the target is 794, and then we are just having that data 100. So now I'm again displaying that linked list. Okay, it's there after 794. Now I will make a call to the insert before as well. So the option is 10, and I want to insert before the first node. So my target is 551 and my data is 50. So insert before was successful. Again, I'm displaying this. You can see that 50 has been inserted as the first node. Again, I will make a call to this insert before. That's option 10, and I'll have a target, say 100, and I want to insert, say 95 before this 100. So let me check that. Yes, 95 has been inserted before 100. So the insert before and insert after has been implemented successfully. You can check the find operation as well. That is going to work fine because we have called that find operation from within insert after and insert method, insert before method. And since these two methods are working fine, so the find operation must be working fine. So that's all for this. In the next tutorial, we are going to implement the delete operations. We'll first implement the delete first, and then delete last, and then delete target. That means deleting any node in between the first and the last. We'll see how we can implement that in the next tutorial. Thank you very much for watching.